Hi there, everyone. In this video, I'm going to show you how to work through this worksheet that you guys are going to be working on asynchronously. This is Exploring the Laws of Exponents, and the objective of what we're going to be doing throughout this activity is kind of exploring what exactly are the laws of exponents and how do I use them in order to simplify expressions. So throughout this, hopefully, instead of just giving you the laws of exponents, you'll be able to think back to these examples and use this while we work through problems that utilize exponents in our learning. So let's get started. Here is what the worksheet looks like. Y'all are able to print this out if you would like, or you're more than welcome to just work through this worksheet in your notebook. I'm not going to do all of it. However, I'm going to walk you through the process and what you should be doing. And I'm actually going to start with the very first part. So you'll notice it says Exploring Laws of Exponents up at the top. There's an option for your name, date, and period or block that you're in. I refer to it as period number, but for example, my name is Ms. P. Today is 110, 2021. Y'all will be seeing this on the 11th though. And I'm just gonna write Algebra 2 for the block. I also have this for multiple classes. So product rule. Okay, so there is a law of exponents that tells us about the product rule, but we're actually going to complete this table and answer the questions that follow to help us come up with what the rule is that represents the product rule. So you'll notice in the table here we have an expression that's given to us, and then we have an area where we need to expand the expression. It's the expanded form part of it, and then we need to come up with what's called the exponential form, or I like to call this the shortcut, but it's definitely exponential form. So the first example here, and I'm kind of regretting I highlighted these already, it says 3 squared times 3 to the 5th. So 3 to the 2nd power times 3 to the 5th power. And we can see expanded out, we have 3 times 3 written twice in blue because that's 3 to the 2nd power. And then 3 to the 5th written as 3 times 3 times 3 times 3 times 3 expanded out, written all the way out. And our exponential form would be the shortcut or the shorthand, right? So I have 1, 2, 3, 4, 5, 6, 7 times that I have multiplied 3. So a way that I could represent multiplying the number 3 by itself 7 times would be 3 to the 7th power. So that's what we mean by exponential form. Let's do the next one really quick. 2 times 2 to the 6th. So I'm going to start off with 2 times 2 to the 6th power is 2 multiplied by itself 6 times. So let's do it. 1, 2, 3, 4, 5, 6. Okay. 2 to the 1st times 2 to the 6th. So let's count how many times we multiplied by 2 overall. 1, 2, 3, 4, 5, 6, 7. So I can represent 2 multiplied by itself 7 times as 2 to the 7th. And lastly, b to the 5th, now we have a variable b, times b to the 8th. What does that look like? Well, I got to multiply b by itself 5 times. So 1, 2, 3, 4, 5. And then I got to multiply b by itself 8 times. 1, 2, 3, 4, 5, 6, 7, 8. How many times did I multiply b altogether? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I did it 13 times. So multiplying by itself 13 times, I can represent that as b to the 13th power. Now, this part says, look at the table above, compare the first and the third column. Describe using words the relationship that you see between them. So this is my first column, and this is my third. So I've got 3 squared times 3 to the 5th, and then I have 3 to the 7th. Okay. 2 times 2 to the 6th, and then I have 2 to the 7th. Interesting. B to the 5th times B to the 8th, and B to the 13th. What relationship do I see between these values? Well, for me personally, after I'm looking at them, I notice that if I'm multiplying things that have, first of all, they all have the same base here, right? 3, 3, 2, 2, B, B. They have to have the same base here in my examples. So I guess it would be like when I multiply I guess this would be like powers with the same base, or like exponents or things with the same base. What happened? I still had that same base, but my exponent was different. So I would say I keep the base, and how do I go from 3 to the second times 3 to the 5th to 3 to the 7th? Well, 5 plus 2 is 7. Interesting. What about 2 times 2 to the 6th? Well, 2 is really 2 to the first. Is 1 plus 6, 7? Oh my gosh. And 5 plus 8 is also 13. So when I multiply powers with the same base, I keep the base and multiply. Nope. Add the exponents. Part number 2 here says use your observations from the previous question to fill in the box and complete the math sentence below. So a to the m power times a to the n power equals a to the what? We just mentioned that we have to add the exponents, right? So looking at my exponents, I have m plus n given in this specific example. The rule I discovered is the product rule. So this right here, you guys might want to write. This is the product rule for exponents. Use it to simplify these expressions below. So these expressions, I have 2 to the 6th times 2 to the 8th. So using my product rule, I know I'm going to keep my base 2 and add my exponent 6 plus 8. 6 plus 8 gives us 14, so I have 2 to the 14th power. Now I have negative 7 to the 3rd times negative 7 to the 1st times negative 7 to the 5th. Whenever there is no exponent present, it's always 1. So this means I'm going to keep my base, negative 7. I'm going to add them up all together. 3 plus 1 plus 5, 6, 7, 8, 9. I have negative 7 to the 9th power. And lastly, I have m times m to the 5th times m to the 6th. Remember, if there's no exponent, we can represent it as an exponent of 1. Using my product rule, I can keep the base and add my exponents. The base here is the letter m. 1 plus 5 plus 6 are my exponents. 6 plus 5 is 11, plus 1 more is 12. So we have m to the 12th power. Cool. Now you're going to continue on and do this for the next few rules in the Laws of Exponents worksheet. The next one being the power rule, and I will demonstrate the first one. Okay, it says And it's going to be the exact same thing where you have a table where it gives you an expression. You're going to have to expand it out, and you're going to look for that pattern. You're going to look for the shortcut or the exponential form. Come up with an explanation that describes what happens. Be as specific as possible. And then using the example given here, the like algebraic example, using like what you've noticed from these examples and how you described it, coming up with a rule and then a few practice problems along with it. So for the power rule here, the first expression we are given is 5 to the second raised to the third power. Okay, 5 to the second raised to the third power. Now, notice this is a power rule and it's raised to a power. That kind of makes sense. Okay, so 5 to the second to the third power means that I'm going to multiply 5 to the second by itself 3 times. So we can see here that I have 5 times 5, that's the same thing as 5 to the second. 5 times 5, that's the same thing as 5 to the second. And also 5 times 5, that's the same thing as 5 to the second as well. Multiplied by itself 1 time, 2 times, 3 times, right? 5 to the second to the third power can be rewritten exponentially as 1, 2, 3, 4, 5, 6. Oh my goodness. 5 to the sixth power. And the reason for that is multiplication is associative, I believe, is the property where you can move it. It doesn't matter if it's 1 times 2 times 3, 3 times 2 times 1, 2 times 3 times 1, 2 times 1 times 3. It all gives you a result of 6. Similarly, you would have 8 to the fifth to the fourth power. So this one's kind of long. 8 to the fifth, and then we're going to raise it to the fourth power. So I have to do 8 multiplied by itself 5 times. So 1, 2, 3, 4, 5, and then repeat it 4 times. 1, 2, 3, 4, 5. That's 2. 1, 2, 3, 4, 5. That's 3. 1, 2, 3, 4, 5. That's 4, right? So I did 8 to the fifth 1 time, 2 times, 3 times, 4 times, which is 8 to the fifth, raised to the fourth power. And if I count up, I notice that I started with the same base and I still end with the same base. I have 5, 10, 15, 20. 8. So I have 8 multiplied by itself 20 times with my exponent being 8 to the 20. Go ahead, do x to the third raised to the fourth, and then describe in words the relationship, come up with a rule. Quotient rule is next. I'm just going to show you how to do the first problem. Again, you're going to do the same thing where you look at the expression, you expand it out, and then come up with an exponential form. So I notice for my quotient rule here that my expression that I'm given is 6 to the ninth divided by 6 to the fourth. Now I apologize, you can't see it super well. But 6 to the ninth is 6 multiplied by itself 9 times. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And 6 to the fourth is 6 multiplied by itself 4 times. So we have 6 times 6 times 6 times 6. Now, with a quotient rule, and you'll notice with the exponential rule, we always wanted to make things as small as possible. So I'm going to rewrite these again one more time, but I'm going to see if I can make some cancellations here to kind of simplify my expression as much as possible. So again, I still have 6 multiplied 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. 6 to the ninth power over 6 to the fourth. 1, 2, 3, 4. And you can see here that we're able to start to cross things out from the top and the bottom. Remember, if factors look exactly the same on the top and the bottom and there's no plus or minus in between them, we are able to cancel them out. So, for example, these 6's will go away, these 6's will cancel each other out and equal 1. Similarly, so will these and these. So if I'm trying to figure out how many I have left, I have none on the bottom, but I have 1, 2, 3, 4, 5 on the top. So I still have 6 times 6 times 6 times 6 times 6, or 6 to the 5th power. And you will want to do that for 100 to the 3rd divided by 100 squared, the letter t to the 15th power divided by t to the 11th power. Describe the words in relationship, come up with a, based on your observations, come up with a rule that represents that relationship with the exponents m and n, and use it to simplify the problems below. And lastly, well, is this the last one? No, we have 2 more. We have power of a product problems. Down here. So complete the table below with a partner and answer the questions that follow. Again, you have 2 times 5 to the 3rd power. So this one gets a little bit more complex. 2 times 5 to the 3rd complicates things in that we are going to multiply 2 times 5 by itself 3 times, right? So I have 2 times 5, and I know you may be tempted to multiply 2 times 5, giving us 10, but I don't want to do that yet. 2 times 5 times 2 times 5 times 2 times 5. That would be the same thing as 2 times 5 raised to the 3rd power, right? Now remember, multiplication, it doesn't matter the order that it's in, right? Like I was saying earlier, 1 times 2 times 3 is equal to 6, but so is 3 times 2 times 1. So I can reorder these to make more sense to myself and kind of put the 2's together and then the 5's together. So I have 1, 2, 3, 2. So I have 2 times 2 times 2. I also have 5 times 5 times 5. 5 times 5 times 5. And I notice I have 3 2's and 3 5's. So if I were going to simplify my expression into exponential form, I'm going to say that this is going to have to be 2 to the 3rd times 5 raised to the 3rd power as well. Again, remember, you're going to want to come up with a pattern that represents the initial expression and the shorthand exponential form. So how does 2 times 5 raised to the 3rd power become 2 to the 3rd, 5 to the 3rd? Hint, hint. That looks like it might be something. I wonder if it's the same for the next few expressions. That will be for you to find out. Again, you're going to look at the table, describe it in words, and come up with a rule based on this algebraic example, and try a few. I will post solutions later. And lastly, we have the power of a quotient rule. So we're going to deal with a quotient, raising it to some sort of power. This is one of our laws of exponents. So for the last example that I'm going to go over with you is 3 divided by 5, that's a quotient, raised to the 2nd power. So I'm going to multiply 3 divided by 5 by itself 2 times. That would be the same thing as 3 to the 5th squared. So I have 3 over 5 times 3 over 5, right? Multiplying it by itself once, twice. That's 3 to the 5th squared. Again, remember that multiplication can be moved around. The order doesn't matter. So I'm going to say 3 times 3 over 5 times 5. If they have the same denominator, I can do that. And again, I do not want to say this is 9 over 25. I want to rewrite it in exponential form. I'm trying to make a connection between the exponents in the original expression and after I expand it out, how I can rewrite it shorthand again, right? Well, the numerator can be represented by 3 to the second power, and the denominator can be represented by 5 to the second power. And I am looking for a pattern that links the original expression and the exponential expression. So I hope you guys get a chance to finish this. Again, I will post solutions. This will be very helpful for us as we work through radical expressions. It doesn't seem like it right now, but just trust me. Trust me, guys. All right, good luck, and I will see you in class.